Here we're given a table of data where the input variable t is the number of years since 1930, and they give me data all the way up to the year 2001. And the output is the population of some town. I am to fit an exponential regression equation to this and round a to the nearest whole number and b to 4 decimal places, and then answer some follow-up questions. Now on your calculator, turn it on, press the stat key here, and then press enter to edit a list. And I purposely put some data here to show you what would happen if you wanted to get rid of it. What you can do is you could hit delete to delete the data, but what I should tell you is never go up to L1 or L2 and press delete or to delete that whole column. So make sure you're on the numbers that you want to delete. Just simply repeatedly hit delete until they're gone. I'm going to right arrow over, hit delete a couple times to get rid of those data, and left arrow to start over. Now you simply type the numbers in the top row, your input numbers, by hitting 0, enter, and then 10, enter, and then 50, enter, and then 60, enter, and finally 71, enter. And then when you hit the right arrow, it'll pop you up to the top of the next column, which is your output column, and then type the rest of the data, 25,908. Once you have the data typed in and you verify that you typed it in correctly, what you need now to do is press the stat key again. And because I want regression, I'm going to right arrow over to the calc submenu. And to get exponential regression, what you're going to have to do is scroll all the way down past number 9, which you would think of as number 10, but it's actually labeled as 0. Press enter. And then on the older calculators, you usually just press enter once, and the assumption is that your inputs X are in list 1 and your outputs Y will be in L2. And mind you that we're not using X, we're using T, and instead of Y, we're using P of T. In the newer calculators, you can go down and till it selects calculate, press enter to get the regression equation. Once you get the regression equation, now I can follow the directions and round A to the nearest number and B to 4 decimal places. So looking at that, that would be A is 26,619, because this digit is a 5. I will round the 8 up to a 9, and it said round B to 4 decimal places, so that would be B equals 0.9932. So I'm going to get, instead of Y equals AB to the X, I'm going to be using T instead of X, and I'm going to be using P of T instead of Y. So we have our population P of T is equal to our A value on our calculator to the nearest integer was 26,619, and the B value that came out to 4 decimal places was 0.9932, and again I'm going to use the letter T rather than X because our input variable here was T. We are on this part now, is the population growing or declining, and at what percent rate. So whether it's growing or declining depends on the B value. If B is bigger than 1, you get growth, and if B is between 0 and 1, you get decay or decline. So our B value is 0.9932, which is less than 1 and bigger than 0. So ours is definitely declining. Now to determine at what percentage rate, we have a few different methods of choice. The way I do it is I look at the fact that when you multiply by 0.99, and I know it's a little bit more, but let's say it's about 0.99, that means you're finding 99% of the population. That means, for example, if I was to plug in t equals 1, you would be finding 99% of what the population was at t equals 0. So let me put it this way. At t equals 0, you have a population P of T of 26,619. And if you were to plug in t equals 1, you would be taking that number, 26,619, and multiplying by roughly 0.99, meaning you're finding 99% of the previous population. So if you're only finding 99% and not all of the previous population, that means you're losing some of the population, so it's declining. And you could describe it this way, that if you're keeping 99% of the population, that means you're losing 1%. So keeping 99% is the same thing. It means losing 1%. So it's declining at about 1%. So you could think of it as I got that number, we're keeping 99%, and if I subtract that, that means that can be thought of as the same thing as losing 1%. But if you remember, it wasn't really 99%, it's about 99.32. So if you let me back up and be more specific, multiplying by 0.9932 means that you're actually keeping 99.32% of the population. So converting this b value to a percentage, you would move the decimal to the right twice, and keeping 99.32% would mean the same thing as losing the percentage you'd get if you took 100 and subtracted 99.32. So if you need help with that, you could go to your calculator, type in 100, and subtract off 99.32%. And if you're keeping 99.32%, that means you're losing 0.68%. Let's go back over here, and you can see that here. Keeping 99.32% means you're losing about a percent, but it turns out because of the rounding we did, it's more like 0.68%. So what percent rate is it declining? You could say that the population is declining 0.68%, but they didn't want just the percent, they want the percent rate, which implies how fast is it going down 0.68%, and it's not going down 0.68% every 10 years or every 40 years, say. The t value here is in years. So every time t goes up by 1, you would keep 99% and lose about 1%, but it actually is the population is declining 0.68% per year. So without the per year, you would not have a rate, right? You have to be changing over some time interval. So that was declining, and since you're saying declining, you're going to not use a negative. You're going to say it's declining at 0.68% per year. So the next question, what was the population of this town in 1985? Well, remember that t is in years since 1930. So if you want, since t is in years since 1930, and we want to predict what happens in 1985, you could see that this is a difference of 55 years. So you would plug in 55 for t, and if you replace that t with 55, you would have to replace this t with 55. So I would type 26,619, and then left parenthesis 0.9932, put a right parenthesis to close the left, hit caret, and then type 55 to find out what the population was in 1985. And I get, because this digit is an 8, that we should round up, and because that is the number 89, we will round it up to 90. So 18,290 people. So we get that P of 55 was 18,290 people. So in this part, it's just the opposite. Rather than giving me a time value, they're going to ask me to find the time value. In what year? What is t? T equals question mark. Did the population reach 20,000? So since P of t, my output variable, is the population, I want to extend this chart to know in what year would my output variable be 20,000. We are plugging it in for the output variable P of t. So P of t would take on the value of 20,000, and now we need to solve this equation. So I'm going to begin by saying that since this number is being multiplied, I could divide both sides by that number, 26,619. And then on this side, since this number divided by itself is 1, it simplifies out, leaving me with just 0.9932 to the t on the right, and I have no idea what this number is on the left. So I will go to my graphing calculator and get an approximation for that. So that would be 20,000 divided by 26619, enter. And for the purposes of writing it down, I'm going to round to 0.75. But when I actually do the calculation, I'm going to use the full accuracy of my calculator. So what I have over here is an exponential equation that I can solve by just changing to log form. And when you change to log form, you start by writing the word log, and then as a subscript on the log is the base. So here's the base and the exponent. The base gets written down here as a subscript, and the exponent gets written on the other side of the equal sign. So it doesn't matter if you put the equal sign here or there, but this base would get raised to this power, which is t. And the idea is if you took this base and raised to the t power, it's supposed to give you this result that you put in parentheses right here, 0.75. So if you wanted to check it and go backwards, because students are better at switching from log form to exponential, you could do that by saying 0.9932 raised to the t power gives you the result of 0.75, and that is the same as this statement up here. Now on my calculator, because I want to show you the change of base formula, I'm going to write this problem as a base 10 problem where you use the change of base formula, which says that this quantity is equivalent to the quantity log 0.75 divided by the log of the base 0.9932. So when I go to my calculator, remember I said I was going to use the common log, but I was going to use also the unrounded version, or I should say the full accuracy of my calculator to evaluate it. So instead of saying 0.75, I'm going to say previous answer. Since this was the last thing I did on my calculator, hitting second negative, we'll draw up the full accuracy of my calculator there, and I'm going to close that parenthesis. So this is really the log of 0.75, and then divide by log 0.9932, right parenthesis, press enter, and that would be using the full accuracy of my calculator to get that it's about 41.9. If you let me round this 8 up, since this digit's a 9, let me round the 8 up to 9, I get 41.9 years. So t is approximately 41.9 years, and if you remember, that's years after 1930. So if you wanted 41.9 years after 1930, you would simply add 41.9 to 1930 to get 1971.9, if you will, which means you're not actually into the year 1972 yet, you're just at the end of 1971. So the question is, in what year did the population reach 20,000? You could say at the end of the year 1971.